Welcome everyone to the STEM student talk of the 6th PolyGen Symposium of Rising Scholars. My name is Sania and I'm a mentor with PolyGens, and I'll be moderating today's talk. The goal of the symposium is to celebrate and showcase the hard work of our PolyGen scholars, and all of whom have tirelessly worked on the projects over the past couple of months. And today, we will have 2 to 4 students presenting in this session, and they'll be presenting on a variety of topics. And then we have a fellow PolyGens mentor who will be scoring each student's presentation, and that will help us determine the prize of the winners of after the event. And if you have any questions, please type them in the chat for each speaker, and we'll allow 2 minutes for questions after each presentation. So the first student presenter we have is Shashvath Srivatsan. Shashvath, are you able to share your screen? There you go. Okay, it's working.
Okay, you guys can see that?
Yep.
All right, so hello. I will be presenting my project on which I wrote a research paper in trends in chronic liver disease mortalities during the COVID-19 pandemic. All right, so I'll just give a quick intro to liver disease just to start. So, chronic liver disease is the gradual replacement of healthy liver tissue by scar tissue, and this is usually caused by alcohol abuse, certain medications, fatty foods, or even as a result of certain viruses. Liver cirrhosis itself is the final stage in liver disease when most of the liver is made up of scar tissue, and usually this leads to the loss of total loss of liver function. So in general, mortality rates do vary based on the stage of the disease, but those with compensated liver disease have a median life expectancy of about 12 years, while those with decompensated liver failure have a median life expectancy of 2 years. Compensated cirrhosis patients show no or minimal symptoms, while decompensated patients experience severe symptoms due to their acute liver failure. And although there is no definitive cure for chronic liver disease, common treatments do include general lifestyle changes, which can include reduced alcohol consumption, losing weight, changes in diet, certain medications, and in extreme cases, liver transplants. So the large burden liver disease has on the US healthcare system make it a priority. So it had an average annual national cost of roughly $17,000, $22,000, and $60,000 for non-cirrhosis, compensated cirrhosis, and end-stage liver disease patients, respectively. Meaning that is how much it costs the average healthcare facility to cure or care for that patient as they get closer to death. So, in the US itself, it is the ninth leading cause of death. In the world, it is the 11th leading cause of death, and it accounts for 2% of the worldwide burden. And just in the US, it has a total of, it costs the US healthcare system and citizens a total of $2.5 billion annually. Oh, okay. So the objectives of my research, what I did was I focused on analyzing yearly trends and quarterly trends for both liver disease and influenza, and I used the influenza as a control. So it was my intention to factor in data from pre-pandemic years, um, so that my results would be free of any data reflecting natural fluctuation. For example, if the mortality rates of diseases are increasing, and liver disease is also increasing, we can't necessarily say that there is a specific external factor that could be causing this increase. By the same logic, if out of a certain number of diseases following a same trend, one deviates from this trend, then there is a possibility that there may be something larger going on. Deaths, I examined deaths at a national level, and I also examined them at a state level. So I chose 3 specific states which I chose based on the severity of those states' COVID-19 restrictions or COVID-19 guidelines. The states I chose were Iowa, Nevada, and Virginia, listed in order of increasing restrictions. My ultimate goal in this research was to provide insight into the correlation between COVID 19 and liver disease and how we can maybe control liver disease mortalities in the future. All right, so during my research, I used public mortality and population data. This was all publicly available. So the mortality data I used included chronic liver disease and influenza deaths, and I obtained it from the CDC, VSRR, and NCHS databases, while the population data was just taken directly from the United States Census Bureau. This raw mortality data, so total deaths, was used. I used that with the population data to derive crude mortality rates per 100,000. These were not age adjusted, meaning as people die naturally or due to the pandemic, the overall population stayed constant. So, in terms of state data, since different states with different characteristics had different mortality rates, I used the percent change from 2019 quarter four to 2020 quarter four to investigate these trends, just to make it a little bit easier to see. All right, so here is what I found with influenza. So the graph to the left reflects statewide quarterly influenza mortality rates, while the graph to the right reflects national quarterly influenza rates. So as you can see in the table above, although it varied by state, the total percent change in the national mortality rate from 2019 to quarter four to 2020 quarter four was only 4%. So despite having a pandemic, the overall rate of change was pretty low, or rate of increase was pretty low. Now, if we look at liver disease, like just like before, the graph on the left reflects the quarterly statewide mortality rates for liver disease, and the graph on the right represents the quarterly national mortality rates for liver disease. And although the graphs are a little bit different, they both show the general same trend, which is an upward sloping line. And this generally starts right after or right during 2019 quarter four, which is when COVID-19 first emerged. When we look at the percent change from 2019 quarter four to 2020 quarter four, we see a big jump. The national jump from 2019 to 2020 is 22%, which is much larger than the expected 4%, which is the general trend that infectious diseases should be following. In the table, we can also see that the percent increase is inversely proportional to the strictness of a state's COVID-19 guidelines. So in the graph on the left, although Nevada is, I apologize, although Virginia is higher than Iowa in mortality rates, Virginia has more strict COVID-19 guidelines. But when we look at the percent increase from 2019 quarter four to 2020 quarter four, we see that Virginia only increased by 22%, while Iowa increased by almost 39%. All right, so these are just additional mortality trends. So the graph on the top here depicts yearly mortality rates, and the graph on the bottom shows total deaths from 2014 to 2020. They both reflect the same general trend, which is an increase starting in late 2019 to 2020, which is when the pandemic started. And this shows that there definitely is this sudden jump, or this sudden increase in the rate of increase of deaths, shows that there definitely is something going on between COVID-19 and liver disease. So, as far as potential reasons for this, three explanations arise. Number one, you have the direct impact of COVID-19 on the liver. Number two, you have the increased alcohol consumption during the pandemic. And number three, you have the restricted availability of healthcare facilities. And it's likely that all three of these contributed somehow to the 22% increase in liver disease deaths. So I'll start with the first one. Patients that have been hospitalized due to COVID have been tested and often show an increase in liver enzymes such as alanine aminotransferase. The buildup of enzymes like these temporarily damages the liver for the entire duration of the illness. For people unaffected by liver disease before they get COVID-19, this isn't a problem. But for patients whose livers are already compromised due to a pre existing condition such as liver disease or liver cirrhosis, this may accelerate the progression of their illness. And following the infection of COVID 19, patients are at risk of increased rates of hepatic decompensation, acute liver failure, and just death due to respiratory failure. Number two, after the initial progression of COVID 19 in early 2020, worldwide lockdowns were implemented, resulting in an extended period of extreme stress and disconnectedness from other people. Unhealthy eating habits and disorders have also seen reemergence during the pandemic, which is another potential cause of the increasing liver disease mortalities. Another was the restricted availability of healthcare facilities for those with non COVID 19 related ailments. A lack of available nearby medical facilities may have prevented some liver disease patients from receiving treatments that they normally would have received in the absence of a pandemic like this one. In addition to this, those with liver disease might have chosen to skip their regular checkups for their liver condition out of the fear of the coronavirus itself, since hospitals were always flooded with COVID 19 patients, especially during the beginning of the pandemic. So, despite the somewhat clear associations reported here, there were some limitations that I have to address, right? So, this data was collected using national databases, and with some numbers being self reported by states, there's a level of internal bias to be expected to preserve the stature of the state. So, a state might not say, a state might report that they have less deaths than they actually do because they don't want to have more deaths than average. They want to be below average or average. Here it's being assumed that the differences in mortality rates of the states of interest is directly associated with the strictness of that state's COVID 19 restrictions. However, there may be some overlooked variables that may also be responsible for this finding. Although states were selected based on their COVID 19 guidelines, other variations or lurking variables may be the cause for these numbers. So, in conclusion, chronic liver disease mortality rates significantly increased during the COVID 19 pandemic. There seems to be some sort of an association between mortality rates and the strictness of COVID 19 restrictions at a state level. As new variants emerge and the pandemic continues, patients with chronic liver disease should be closely monitored, and states should better incorporate this high risk population into public health decision making and future directions. So when I was writing this research paper in late 2021, I only had access to data up to 2020 quarter four, but recently the CDC VSRR database published new data for 2020 quarter one. So I apologize, 2021 quarter one and 2021 quarter two, which is when this is first when national guidelines were relaxed. So this may provide further insight into the results of my research. So I could maybe develop it that way. Also, because the data from only 3 states was analyzed, the direct trends may still not be entirely defined. So, looking at the same mortality data for different states could help determine any new changes here. As far as acknowledgments go, I want to thank Shashvath Srivatsan, my mentor, for his guidance throughout the process of my research. And obviously, this would not have been possible without the assistance of my family members and friends to whom I extend my sincere gratitude. Recently, my paper was accepted for publication in the International Journal of High School Research. Thank you.
That's great. Thanks so much, Shashvath. This is now we have some time for questions. If you have a question, feel free to put it in the chat, or you can click the raise hand button and we will unmute you for you to ask your question. Okay, we have a question. You can ask your question. So Kamal. Kamal, we unmuted you, but we can't hear you. maybe you can try typing your question in the chat instead because we can't hear you. Okay, so the question is how long it took for this topic from concept to publish?
I think like the whole process took maybe 4 or 5 months. Like the planning, like once the planning and all the numbers were crunched, the actual writing process was definitely pretty smooth. I'd say the hardest part was definitely like the crunching of just the raw numbers and making sense of that.
Okay, anyone else have a question? If not, we can move on to the next presenter. So Somu Singh will present next.
So is my screen visible?
Yep.
Wait, so let me just share it so you can confirm. So is it visible?
Yes, we can see.
Yeah. So hey everyone, my name is Somu Singh. I'm a first year student at the University of Lucknow in India. So me and my mentor Anna ma'am worked on this review type research paper titled Neurodegenerative Disorders Today and Tomorrow. So neurodegenerative disorders, as for the introduction part, they are those disorders which result in degeneration or loss of nerve cells. They are a major concern in today's world as they take away the quality of the patient's lives. As you can see from the data that is written in this slide, that as the average age of the elderly population, I'm so sorry, the percentage of the elderly population is increasing from 7% to 12%. These disorders are a major concern as they generally affect the older people in particular. So I took around 17 papers to develop this review. Uh, okay, so the three disorders that we focused on were Alzheimer's, Parkinson's, and Huntington's disease, and we analyzed these three on three major aspects, namely epidemiology and etiology, which describe the prevalence of these disorders and the brain regions that are affected. Then the second aspect was the behavioral aspect, describing the behavioral symptoms. And then we analyzed the current treatments available and potential future treatments for these disorders. At the end, we made a table of similarities and differences comparing these disorders. So this research paper is intended to serve as a basic overview for further study on these types of disorders so that they can improve the lives of elderly people. So let's move on to the first disorder. So Alzheimer's disease is perhaps the most well-known of the neurodegenerative disorders that we are talking about. It manifests itself usually in elderly people over the age of 65 in the form of symptoms such as memory loss, behavioral changes, and some cognitive impairments. According to a study, it is the fastest growing cause of death in the United States, and it accounts for almost 50% of all dementia cases. So the brain regions that are affected, that are majorly affected, and the neuronal loss, it occurs in the region of the neocortical, hippocampus, and the cerebellar regions of the brain. Even the corpus callosum is affected here. So the cause of this disease is, as has been described by many research papers, is due to the formation of A beta amyloid plaques, which are just aggregates of proteins that form in the spaces in between the nerve cells. So these mutations occur due to mutation in the amyloid precursor protein. And this A beta amyloid is a protein that is found widely expressed in the body, but its function is is currently not widely known. So there are also some genetic factors and environmental factors at play. There's something called the presenilin genes, which are also involved here. So to describe the brain regions that are affected, let me just zoom in on this first figure. So so in Alzheimer's disease, not just one region, many regions are affected. So one region could be this neocortex region, which is colored in yellow in this part. And then second could be the cerebellum, would be the cerebellum. That is the smaller, small brain-like structure. Below the brain, it forms like a ball-like structure at the base, this pinkish structure. And then the hippocampus is the reddish line at the base of this third structure, and then the corpus callosum. So in these four regions and other regions as well, neuronal loss occurs, which causes the symptoms that were described earlier. So now let's come on to the behavioral aspects. So one of the major consequences of Alzheimer's are the non-cognitive behavioral changes, or some may call it as the behavioral and psychiatric symptoms of dementia. These include symptoms such as depression, agitation, anxiety, apathy, sleep disorders, etc., with the depression and apathy being the most common of them. So a study in 2019 described that personality and Alzheimer's disease are closely linked. So this could also be the reason why the patients affected with Alzheimer's disease have some defects in their personality as well. So, and unfortunately, there is no cure available yet for Alzheimer's disease, and the treatments mostly involve management of symptoms. So early detection is the key. So a paper in 2009 described the three types of strategies that could be potentially used in Alzheimer's disease. So these included primary, secondary, and tertiary. The primary one involved the potential etiological factors, or the cause, you could say, the brain regions that were affected. They could be monitored. The secondary was based around early detection, which, as described earlier, is a key for management of symptoms at an earlier stage. And the tertiary ones focused on improving the quality of patients' lives. And a study in 2018 described that antioxidant properties from some plant extracts and natural products could also be used as an intervention in these disorders. And as genes are also an important factor in the cause of this disease, perhaps research could also be done in the fields of genetic engineering and all that. So now let's move on to Parkinson's disease. So this disease is also widely known, but the thing is that this is mostly known for its motor impairments. But let me tell you that it is also a major cause of behavioral impairments as well. So unlike Alzheimer's disease, the exact cause of Parkinson's disease is unknown. So we use a term known as idiopathic to describe this aspect. It can also affect younger people apart from the elderly, which was more of the case in Alzheimer's disease. And so the neuronal loss, as is common in all neurodegenerative disorders, occurs in the substantia nigra region, which, if I can show you, is this red dot in the left diagram, red dot, and also some impairments occur in the basal ganglia, which is the reddish portion in the right diagram. Yeah. So the neuronal circuits that are affected are usually responsible for the motor functions. So when they are affected, so the motor impairments occur. But that isn't the only dangerous aspect of Parkinson's disease. And in fact, we should also focus on the non-motor symptoms, which are the behavioral aspects. So in the behavioral aspects, the symptoms include depression, apathy, anxiety, even hallucinations. And as I've also described the classic motor impairments, or something that is usually known, such as resting tremor, rigidity, and all that. So these would be the behavioral aspects. And sadly, even for Parkinson's disease, there is no cure available yet. And the diagnosis involves the detection of Lewy bodies, which are some sticky protein lumps in the brain. But as the behavioral aspects also play an important role, and early detection is a key factor for management of symptoms. Maybe the behavioral symptoms could also be used for diagnosis at an earlier stage. The most common drug that is used as an intervention is levodopa, but it has some complications which should not occur, because motor symptoms are also a major cause of this disease. Yeah. So for future treatments, perhaps therapy based on caffeine could also be used, as described by a study by Paul and Lin in 2018. Now, moving on to Huntington's disease. This is mostly a genetic neurodegenerative disorder, and it is also characterized mostly by motor symptoms, but there are also some behavioral symptoms at play here. Here, the cause, you could say, is the mutation in the Huntington gene, which, as described here, is just an expansion of this codon, CAG, we could call it. Yeah. And the neuronal loss, as it is a neurodegenerative disorder, occurs in the striatal part of the basal ganglia, which, if I can show you, is this green portion in the center of the brain. So neuronal loss occurs in this region. Now, coming on to the behavioral aspects, the difference between the motor symptoms of Parkinson's and Huntington's disease is that in Parkinson's, while there are some motor impairments, in Huntington's disease, these motor impairments occur with a jerkish kind of behavior, jerkish kind of movement. And the psychiatric symptoms include anxiety, apathy, and even irritability is a major symptom. Yeah. So next week, in the current and future treatments part, even Huntington's disease sadly doesn't have a cure, and the methods administered usually include management of symptoms. And a study described that even exercise can also be used as a tool to serve as some sort of management therapy for Huntington's disease patients. And at the end, we made this table of similarities and differences. So as you noticed in the previous slides, that though there were many differences in the etiology or the neuroanatomy part, you could call it, there were many differences because the brain regions where neuronal loss occurs were different, but the behavioral aspects were similar in most of these diseases, apart from the motor impairments. But the psychiatric symptoms were more or less the same. As you can see here, these were just such as agitation, apathy, depression, etc. So concluding this presentation of mine, so as you can see that these diseases might have some similar behavioral aspects, but the origin of these diseases is really different, because Alzheimer's and Parkinson's are proteinaceous, and so another one is idiopathic, while Huntington's is primarily a genetic disorder. But still, these three are neurodegenerative disorders. And I have also already mentioned the behavioral changes that occur in these disorders. And there is no cure available for this disease. So what was the purpose of this study was that we wanted this to serve as a basic overview for further research down this line, and the researchers could use a comparative and holistic approach to these disorders, because the behavioral symptoms were similar in these three disorders. So perhaps they could be traced back to the regions, and we could then perhaps make another studies that would combine the treatments of these diseases, and that could perhaps lead to a breakthrough in the future. Yeah, so thank you very much for bearing with my presentation. So let's move on to the Q&A section.
Great. Thank you so much for your presentation. So again, you can feel free to enter your question in the chat or click the raise hand button. We can invite you to ask your question live. Any questions for Somu? You just did such an excellent job. Here we go. Anna has a question. Was there anything surprising that you learned while doing the research paper?
Yeah, well, I hadn't expected these diseases to be so much similar. Well, so at the end, we reached on to this that they were quite similar. So perhaps a holistic approach could be taken, because usually they are, studied in solitude, and a comparative approach is not taken. So perhaps that was a bit surprising for me. Any other question?
Okay, great. Thank you so much for your presentation again. So we'll move on to the next presenter,
Thank
which
you
is
so much.
Hansini. You can share your screen when you're ready. Okay, great. We can see that. And then don't forget to unmute so we can hear you.
All right. Hello, everyone. My name is Hansini Ramachandran, and my polygens research paper was on the quantum origins of negative mass cosmology. Is everyone able to see my screen?
Yes, we can see.
Okay. So before I get started, here's a little bit about myself. Apart from my growing interest in physics, specifically quantum physics, I really enjoy business and marketing. I'm a part of my school's DECA club, which is a business club, and I've won multiple awards. I love to run and have been a part of my school's cross-country and track team for the past 3 years. And lastly, I love to sing, and I've performed many solo Indian classical music concerts. All right, so let's jump in. Here's an introduction to what negative mass cosmology is and why is it important. So scientists have realized that there's more in the atmosphere than what they can see or measure, and that more is what they call dark matter. This dark matter research can be traced back to Einstein, Kapteyn, or Oort. But more recently, scientists have applied properties discovered about dark matter and negative mass fluids to explain the general field of negative mass cosmology. My paper reviews the recent universal framework of NMC, and along with events such as black holes, anisotropies, friction, symmetries, and others that are being explained using this cosmology. So here's a general overview of the different concepts I examined during my research. So under this field of negative mass cosmology, it's been used to explain both astronomical and classical physics concepts. Under the astronomical concepts, I analyzed black holes and anisotropies. And under the classical physics concepts, I analyzed friction in black holes and CPTM symmetry, which is charge, parity, time, and mass. So here's some important vocabulary to negative mass cosmology. Firstly, a black hole is defined as a region in space where gravity is so strong that nothing can escape, not even light. Anisotropies are the states of exhibiting different properties, such as size and density, when you're measuring them on different axes. And finally, Einstein's cosmological constant, which is just referred to as a cosmological constant, is an arbitrary constant used in general relativistic equations that is a leading candidate for dark energy and therefore the expansion of the universe. Okay, so what is the recent universal framework of NMC? Like I mentioned earlier, negative mass cosmology is a way to explain the development and growth of the universe, assuming both positive and negative mass particles exist. So the universe began as a bundle of positive and negative mass particles that expanded infinitely due to runaway motion. So what is runaway motion? As you can see in the picture here, it's an interaction between positive and negative mass particles. The positive particle is repelled from the negative particle, while the negative particle is attracted to the positive particle. So this causes uniform accelerated motion in one direction, which is called runaway motion. Now, the Farnes 18 model, which is the widely accepted model for NMC, is where he states that he united dark energy and dark matter into one single negative mass fluid that is constantly produced in order to maintain the density of the universe by countering some of the density of the positive mass particles. He claims that according to NMC, the universe is less than empty. Farnes then uses concepts such as runaway motion, degeneracy, and the Friedman equation to prove his unifying theory. Now, there are some modifications to the Farnes model. And for example, Chung and his colleagues say that although Farnes' model suggests that dark matter was formed repulsive, they think that it was not repulsive until it was made so by baryonic gas, which is just gas made of protons and neutrons, but no electrons or neutrinos. Regarding the source for dark energy, it is suggested and proven by Chung that symmetric positive and negative mass universes exist, which explains the 68.6% composition of dark matter in the universe. All right, so the methodology and study of my paper. The first part is where I analyzed the astronomical concepts being explained by NMC. The first concept was black holes and supermassive black hole formation. Manuel Palomo in his paper uses negative time and energies to explain supermassive black hole formation and collapse. He justifies his claims using the Schwarzschild solution. He does bring up some paradoxical problems of negative mass cosmology, such as perpetual motion or time travel. But because negative mass particles still have a positive density, they must have a negative time with respect to the conventional direction of time. He also says that bigger black holes grow faster than small ones, and they evolve into supermassive black holes due to their expanding event horizon. Palomo then concludes that the negative mass creates an outward bounce in space-time, as opposed to reaching an inward gravitational singularity. And this could be used to explain some bigger mass measurements, such as ones made by LIGO. The next concept I examined was cosmological anisotropy, explained by NMC. In his paper, Stefan Kor explains how component particles can explain the shape of the universe. He analyzes a study by Max Planck and provides evidence for large anisotropies. He explains how linearized general relativity, although possibly confused with electromagnetism, is different from the latter as it has symmetrical effects. He also states that negative universes must have an effect on our universe, and that runaway motion results in primordial inflation, which is the constantly accelerating and expanding growth of our universe. He delves into what a segregation state is, which is the overlap of positive mass and negative mass universes. And finally, he concludes that the distance between antimatter universes must be different from the distance between matter universes. The third concept I examined was friction from dark matter, and can it solve the constant problem? Dina Traykova and her colleagues discussed the possibility of light bosonic scalars, such as axions, to solve the cosmological problem in quantum chromodynamics. Axions are basically hypothetical elementary particles. She and her team conducted this research through a numerical simulation measuring the dynamical friction of a black hole moving at a relativistic velocity. They concluded that the model and study can be applied to other bosonic candidates, in addition to axions, to determine if they qualify as dark matter through a friction-based measuring approach. And this is a great example of how quantum physics and NMC have been paired together to explain phenomena such as the existence of bosonic scalars using friction. And the last concept I examined was CPTM symmetry, which again is charge parity, time, and mass. And can that solve the cosmological constant problem? Sergei Bondarenko writes about the consequences of CPTM on the value of the cosmological constant and the problem of vacuum energy density. He extends Einstein's equations, and the cosmological constant is proven to be a dynamic variable, which is one that doesn't stay static. It changes depending on the circumstance. Its small yet non-zero origin is a result of its quantum element. And the immediate consequence is a zero density and zero electrical charge on a classical level, making it free at first of baryon asymmetry and no vacuum energy. They suggest the model for a cosmological constant is a result of the quantum properties of the vertices that hold the two manifolds together. Quantum manifolds are basically infinite dimensional manifolds modeled by Euclidean space. Finally, this paper indicates that another source for dark matter could be quantum tunneling through manifold vertices. However, this theory has not been explored much yet. As for future directions, future research on the applications of NMC should avoid classical equations in order to maintain the origin and integrity of the concept. I concluded that in addition, rather than using NMC to explain classical phenomenon, it should be a continuation of current research explaining other cosmological occurrences, such as superfluid spacetime, sterile neutrinos, or quasars. And here is a negative mass cosmology timeline I created. As you can see, the paper published in 2014 was a Farnes article, so that was the very first time negative mass cosmology had been explored. Over all the other papers I read, there were only small modifications to this Farnes model, and most of the papers were describing different astronomical and classical concepts using this cosmology. Thank you for listening. I would like to especially thank my mentor, Ms. Valerie Say, for guiding me through this process. And I would like to thank Polygens for giving me this wonderful opportunity. My paper is currently in peer review at the Young Scientist Journal. Are there any questions?
Thank you so much. So again, we can take questions in the chat, or if you raise your hand, we can invite you to ask your question live. Anybody has any questions for Hansini on her presentation?
I see one in the chat. It's what sparked your interest in the subject matter? That's a wonderful question. In fact, when I went into my Polygens project, I was set on doing something in quantum physics. A couple years ago, I had chanced upon an episode on Amazon Prime of a show called Quantum Mechanics, and that was really, really fascinating. After watching multiple TED Talks and videos explaining things like the Schwarzschild solution or the Heisenberg uncertainty principle, I was really fascinated by the concept. And I read a book called Infinity Puzzle, which was about quantum thermodynamics. And it was also really fascinating. So going into Polygens, I was really sure I wanted to do quantum physics. But after researching and reading a bunch of articles on, the new papers that came out in quantum physics, I somehow landed on this topic of negative mass cosmology. And I found it really fascinating. Like, I didn't know there's something as negative mass. Like, at first I was like, how can a particle even have negative mass? And so I found that really fascinating. And I researched it a lot. And I found that there's a whole different field of cosmology to it.
That's awesome. So thank you again for your presentation. And that wraps up this session. So we only have 3 presenters today in this session.
Before I wrap up, I see one more question in the chat. Would it be okay?
Yeah, it just came in. Yeah.
So the question is, do you think that your research in negative mass cosmology can be applied to other fields as well? And I think that's a great question. So some of the research papers I examined, the expert research papers, they have applied negative mass cosmology to both astronomical concepts and classical concepts. So I think, yes, it can definitely be applied to all forms of physics, from quantum to condensed matter to classical to astronomical. But I think if it is, as I said in my future direction slide, if it's mainly used for expanding and growing the field of astronomical physics, that would maintain the integrity of the field, because negative mass cosmology uses, general relativistic equations, which sometimes won't yield sensible and able results for classical problems, and therefore it should be used mostly for astronomical physics. Thank you.
Great. Do we have any more questions? If not, then I just want to thank everyone for attending the session today. These students work very, very hard, so appreciate your time. And so hope everyone enjoys the rest of the symposium. Thank you.